Hello everyone, welcome to the second part of our video lecture. Hope all of you are safe, stay at home, stay safe. We already discussed different types of voltage source inverters, that is stepped wave inverter and PWM inverter. In that we discussed advantages, disadvantages and different scheme of induction motor drives using these inverters. Here you can see the output voltage waveform of a stepped wave inverter and a PWM inverter. Here first one is the stepped wave inverter line voltage waveform, which is almost equal to a square waveform shape. Here it is modulated output voltage waveform in case of PWM inverter, and this waveform is more closer to the sinusoidal waveform than this one, and you can write line voltage and phase voltage equation for this stepped wave inverter like this. To line voltage equation is 2 root 3 by pi Vd into sin omega t minus 1 by 5 sin 5 omega t minus 1 by 7 sin 7 omega t, etc. And phase voltage equation 2 by pi Vd sin omega t plus 1 by 5 sin 5 omega t plus 1 by 7 sin 7 omega t. And you can see the lot of odd order harmonics are present in this output voltage waveform shape. And RMS value of the fundamental phase voltage, you can return it as VAN is equal to root 2 by pi Vd. Vd in this expression is the input voltage of the inverter. Fundamental component of output phase voltage of PWM inverter is given as V equal to M into Vd by 2 root, where M is the modulation index. From this equation you can see that by varying the modulation index you can vary the output voltage. Okay, so let's see different features of PWM inverter compared to stepped wave inverters. In a PWM inverter, no need of varying the input DC voltage. You know that in PWM inverter both the voltage and voltage control and its frequency control is available within the inverter control, hence no need to vary the input DC voltage, so you can use constant DC link voltage. Also, output voltage waveform is so much improved compared with the stepped wave inverter output voltage waveform, because it is more sinusoidal than a stepped waveform, stepped inverter waveform. Also, minimum torque pulsation in case of a PWM inverter, that is the variation in the torque is minimum when you are using PWM inverter compared with the stepped wave inverter. And you know that no need of input voltage variation is required in case of PWM inverter, so we don't require any controlled rectifier at the input side. We require only the diode rectifier, so the power factor is improved. And 4-quadrant operation is possible. Dynamic braking can be employed. It can be suitable for single and multi-motor drives. Also, most of the VSI fed induction motor drives are supplied from AC supply, and you can achieve the regeneration. That is, in order to make regenerative braking, we need regeneration. That is, induction motor should be works as induction generator. In that case, we should have some converter which is having a bidirectional power flow capability. That is either fully controlled rectifier or a dual converter. So these are some of the features of PWM inverter. Let us discuss the closed loop speed control of VSI fed induction motor drives. Before coming to this, let us remember in your first module, we already discussed a closed loop control structure, closed loop speed control structure. In that, you might remember outer speed control loop and inner current control loop. The similar structure we drawn in the third module also, that is closed loop speed control of DC motor drives, which allows the speed control below and above the base speed. Hope you all remember that control structure, control block diagram. In a similar fashion, here also we have closed loop speed control of VSI induction motor drive using this VSI, voltage source induction motor, voltage source inverter fed induction motor. Here we have inner slip speed control loop and outer speed loop, that is inner slip speed loop and outer speed loop. Outer speed loop is similar to as that of a DC motor drives. Instead of inner current loop in DC motor drives, here slip speed loop. And before proceeding, you should understand what is slip speed. Slip speed is nothing but it is the slip into synchronous speed. All of you know that what is a slip equation. Slip equation is S equal to Ns minus Nr by Ns. Ns minus Nr by Ns, which is equal to slip. From that equation, Ns minus Nr is equal to slip into synchronous speed. Ns minus Nr is equal to slip into synchronous speed. That slip into synchronous speed is known as slip speed. Now, slip speed is equal to Ns minus Nr. That is, difference between synchronous speed and the rotor speed is the slip speed. So, whenever the variation of the rotor speed occurs, there will be the variation in the slip speed also. So, variation in the rotor speed is sensed using an outer speed loop, and it is given to slip speed loop, and slip speed loop is actually giving the command accordance with the variation of the rotor speed. So let us move on to the complete block diagram of closed loop speed control of VSI induction motor drives. You can see that block diagram. Here, this is the complete structure. You should understand this part. This part is speed sensor, then speed controller, slip regulator, and this is synchronous speed frequency. This part is actually the outer speed control loop. That is speed control loop. Inside there is a inner slip regulator, slip control loop. So this part actually ensures the speed control of this induction motor, but we should have another loop here. This loop is actually voltage control loop, because this entire control structure is for induction motor control by using V by F method. You know the basic theory of V by F control in last module, where voltage and frequency is voltage and frequency are simultaneously varying in order to keep flux as constant. So by using this loop we can vary the speed, but you should ensure voltage also should be vary in accordance with the constraint. Flux should be constant, or ratio between voltage and frequency should be constant. And let's see what is the working of this. Then speed is sensed. Then this rotor speed is compared with the reference speed. This difference gives the error. This error is processed to a speed controller. It either be a PI controller. And then this error is the input, error is the input to the speed controller, then command from the speed controller is given to slip regulator, and depending upon the value of error, a large value of error, then slip regulator will set maximum value. Accordance with the current also become maximum, and this motor will drive accelerate. So this output of the slip regulator is omega SL, that is the slip speed, reference value of slip speed. Slip speed is S into rotor synchronous speed. Slip speed is S into ns, that is this one, and we added actual rotor speed with the slip speed, you will get a synchronous speed. This you can realize from the equation. Slip is equal to omega ms minus omega m by omega m, that is slip is ns minus nr by ns. From that, synchronous speed is s into ns plus nr. S into ns is this one and nr is this one, that gives the synchronous speed. So this fixes the frequency, but we need voltage information in order to make V by F as constant. So we have another loop, it is voltage controller. This voltage reference is actually calculates from the information flux control block. Information from the flux control block, we set V star, and this frequency is set by this speed and slip regulator control block. So V by F is constant, but we are varying the speed. Suppose if there is a positive speed error, omega m star is higher than omega m, then positive speed error, then the error is processed, then slip regulator will set maximum value, then driver will be accelerate, then omega m increased, then this error will be again minimized. This loop will be continuous until this error become 0. And whenever this loop is working, in every loop action, the same time the voltage controller also works from the information from flux control block to make this V by F as constant. So remember that this M modulation index is the term by the variation of modulation index, voltage is varying, as I told in previous slides. So by varying the voltage, by varying the frequency in such a way that V by F as constant, the entire control system works. Hence you can read out all these points. These points I have discussed here. So you can read out these points to get more idea, and you should study this complete control block diagram and this simple explanation in order to explain the VSI fed induction motor drives. And basic theory of V by F control we studied in last module. That also you should remember. You can club that explanation with this explanation in order to give the complete explanation of closed loop speed control of VSI induction motor drives. So we will discuss CSI fed induction motor drive in the next video lecture. Thank you.